I'm Noah. I'm the CTO from DFNS. We're sponsoring that happy hour in Jersey City later today. Please come to it. It'll be fun. I'm sorry it's all the way on the other side of the city. But anyway, I just wanted to give a quick update on Lockness. So Lockness, this is a multi-party computing project that we've built internally at DFNS, and then we open sourced it and then brought it under the Hyperledger Foundation. So we've had some great updates this year. So first, we released a bunch of security fixes for CGGMP 21, which is a pretty well-known signing protocol. We coordinated with quite a few people in the space on this, Fireblocks, Blockdaemon, and a few others. And more importantly, though, we released CGGMP 24, which is an update to the signing protocol. So this is for ECDSA signing. And the 24 protocol, it ironically has all the fixes from 21 already in it, and a bunch of other stuff, which is great, and it's a little bit faster. One big change that we made GMP optional. So we love GMP. It's AGPL licensed, though. Makes it a little difficult for a lot of corporations to use and bring into their systems. So it's optional. We also did a lot of performance work on ZK operations if you're using GMP. So a lot of great work there. And then we did an update to what we call our round-based framework. So this is if you're developing an MPC protocol, like a base framework for doing the communication in MPC. So we just released some new features to make it a little easier to use. And then finally, the most exciting part, we started work on a PQ algorithm. So we're implementing MLDSA as a first step for threshold signing. And then what we're also looking to do is build in key independent pre-signatures. This is still in the research phase. We have this in our systems that we run. Looking to potentially open source this as well, but it's a very nice feature and it provides very fast signing. I'm not sure how the sign is going to be on a PQ algorithm. Probably a lot slower than what we're used to, but should be interesting. So anyway, that's the entire update. Sticking to the very lightning format here. Happy to take any questions, though. I'm just the looks. I'm definitely not the research team. We unfortunately couldn't have them here, so any tough PQ questions, feel free to send them my way, and I'll get them routed.
Any questions? Can you talk more about your company history? What I know it's a wallet as a service.
Yeah. Well, you nailed it. Wallet as a service. We like to think of us as like a blockchain operating system. Maybe not like the right word to use, but just if you want to operate on chain, we provide kind of everything out of the box that you need. So signing, key management, key storage, blockchain indexing, different signing algorithms, things like that. So that's kind of what we do as a company. All the MPC stuff, we use it internally. We love MPC. We also support HSMs. We've done a pretty big partnership with IBM. So we power IBM Digital Asset Haven too.
So do you maintain users and private keys?
We do, but we also let people, like mostly custodians, banks, they want to retain the key material themselves. So they'll host the key material, but we operate on like a hosted key model. So there's blockchain first came out. There's a lot of not your keys, not your coin, which is great. I love the mentality, but for most users, maintaining a private key is actually pretty difficult. So we follow like fairly standard requirements where user authentication is totally separate from key management.
Does user create an account with your service or they just use their private key to manage your private key?
So they would create an account with our service, and then everything that we do is asymmetric key based. So you'd register like a WebAuthn passkey, and then that would be your authentication into the system, and then you could manage all of your key material. Yeah.
I have a question.
Mm-hmm.
So reading through your GitHub page, so that like you implement Frost.
Yeah.
So I would like you to talk a bit about like how your Frost implementation works. for signing, like some sort of DKG, like between 16 participants.
Mm-hmm.
Then every round, these participants contribute their key share for like some signing. How does yours work?
Fairly standard MPC. It's very fast, and I don't have like specific details on the implementation. But yeah, I mean, it would be you'd set up your signing threshold, your signing cluster, and say it was like 3 of 5, then you would do 3 of 5 signing, something like that.
Okay.
Yeah,
Yeah. Right now we have a problem of rounds.
yeah.
Like for a round of 16 participants, if you do 4 rounds, that is going to take a lot of time. So like
I think we're much lower than that on the rounds. I think it's 2 rounds in our
2 rounds.
implementation. But don't quote me on that. Double check the code. But like typically we get a signature out in like 100 milliseconds or less. So it's really fast.
I would say if you have any more questions, just grab Noah or grab anybody else who spoke. Why don't we take a 15-minute break or so? Let's be back around 11, and we'll do an interoperability discussion. We'll start with cache management